So the review for day 5 is all about exponent rules. So we can see at the top, before we jump into examples, we've got 6 of our exponent rules written out here. Okay. The product rule says that if you are multiplying like bases, meaning see how these are both base A? Okay, you have the base of the exponent is the number that's being raised to the power. So these are both base A, and they're to different powers, okay? And these two values are being multiplied. When that happens, product means multiply. You can condense this, meaning you can combine it to a single base A and add those exponents. Okay, so the product property, you condense from multiplying the bases to adding the exponents. Okay, and in line with that is the quotient rule. Quotient is when you divide. Okay, so the opposite of multiply is divide. The opposite of add is subtract. So if you have like base terms being divided, you will subtract their exponents when you condense them or combine them to a single base term. Okay, so that's product and quotient. Now the power rule is talking about if you raise an exponent to another power. So you have a power on a power or an exponent on an exponent. Okay, when this happens, you are going to multiply. That's a dot between the M and the N here. You're going to multiply those two exponents and just keep your base as is. The expanded power rule is the same thing. It's just when your base is a fraction. So I've got an A over B base, and then outside the parentheses is an exponent. That means that the exponent is going to both the numerator, the top, and the denominator, the bottom. So A gets raised to the power of M, and B gets raised to the power of M. Okay, and then your product, the power of product, is saying if you are multiplying two different bases, and those are in parentheses, and then outside parentheses, you have a power. That power goes to both bases inside. Okay. And then the zero power rule means if you raise anything to the power of 0, except for 0, but if your base is anything other than 0, if you raise it to the power of 0, it's going to be 1. Okay, so it can be 1,000,000 to the 0 power is 1. 10 to the 0 power is 1. -8 to the 0 power is 1. Anything to the 0 power is 1. Okay, so those are the rules you're going to reference as we go through these examples. So in example 1, we can see these parentheses, these two sets of parentheses. I'm going to look inside each set and see if there's anything I can do within the parentheses before I try to multiply these. So inside this first set, I've got -3, I've got a base B and a base D. So I can't combine anything in here. Same over here. I've got a base B and a base D. I can't do anything. But now when I go to multiply these, because remember when you have the parentheses up against each other like that, you're multiplying. So when I go to multiply, I'm going to multiply the like parts, the corresponding parts, if you will. So I'm going to try and color code this. So if there's a coefficient, a number, okay, multiply it by another coefficient or number, okay, and the other, ooh, not like that. There. So that's just a -1 understood right here. It's just a negative sign. So this is like doing -3 times -1, and that's just going to come out to +3. Okay, and then I'm going to do the same thing for, oops, that was just to stay orange. My highlighter, I want to switch. Oh my gosh, stop. All right, now the base B is raised to, oh my gosh, this is going to drive me nuts. colors are not switching when I try to get them to switch. Pen, orange, 3. Highlighter, blue. Okay, so the B is to the power of 2, and this B is to the power of 2. And these are being multiplied. So I'm actually going to write that out so you can see what's happening here. I'm multiplying B squared times B squared. Okay. And then in green, I'm going to multiply the D times the D. So what happens here, if you want to list out over here, instead of just going ahead and doing that 3, maybe it would be better if we have a line where it's all, we're doing a -1 and a -3. So I just rearranged all the terms. I organized them and I put the numbers together. I put the B's together and I put the D's together. Now to actually do the math, -3 times -1 is +3. Okay, B times B, that is going to use this power product rule up here where the bases match, we add the exponents. So I'm going to add 2 plus 2, so that's going to be B to the 4th. And then we're going to do the same thing with D. Right now, if there's no power, it's an understood 1. So if I add those two, 1 plus 1 is 2. So D squared. Okay, so I reorganized to group together what's going to get multiplied. And then I used the, in this case, the product property. Okay, so in number 2, I've got the first, it starts to look similar at first, but then you see these exponents outside the parentheses. So that means that this exponent is going to go to all 3 of these bases in here. So this -3 is going to be cubed. This A squared is going to be, not squared, cubed. And this B is going to be cubed. Same thing over here with this power outside an exponent. It's going to go to both bases. The A is going to be squared and the B squared is going to be squared. Okay, so this time I am using the power property and the this last one that we talked about up here. So we're using a couple. We're using the power of a product where we like distribute that power. Okay, and now we've got powers to a power. So we're using this power rule here where we're going to multiply those together. Okay, so now that we have it ready, this is going to come out. -3 cubed means -3 times -3 times -3. So it's going to come back out negative, and 3 times 3 is 9 times 3 is 27. So I've got -27. And then here I multiply these powers. 2 times 3 is 6. So A to the 6th. B did not have a power before, so now it's just cubed. This A is squared. And here I multiply 2 times 2, so that's going to be B to the 4th. But now I've still got some matching bases that I can combine. So I'm going to rearrange this. If you don't need the line of rearranging, maybe you can just underline like this. Okay, I'm going to put the A's together. I'm going to put the B's together. So the -27 is going to stay. And then A, I'm going to add its powers. So 6 and 2. So A to the 8th. The B's, I'm going to add those powers. So 3 and 4 is 7. So B to the 7th power. That's as far as I can take it. I used 3 of the different properties there. Okay, I'm gonna go ahead and do number 4 so I can leave that little part up on screen if you're still writing. So this one, we're gonna use quotient property. We're dividing, but we're gonna still do group the same. So the numbers, 16 divided by 2, that's 8. Okay, now I'm gonna draw a fraction bar because when I subtract these powers, okay, 3, and this is an understood 1. So 3 minus 1 is 2. That's a positive 2, so it's going to go in top, x squared. But here, 4 minus 6, see how the 6 is bigger? So my difference is 2, but it's got to be in the denominator. So the y squared has to be in the denominator because 4 minus 6 is negative 2, so that means to put it down here. Okay, wherever if you've got matching bases in numerator and denominator, top and bottom, okay, whichever one is bigger, that's where you're going to keep that base. And that's as far as I can take this one. Okay, let's take a look at number 3. Now before, I can do 2 things. I can do my dividing first and then distribute my power, or I can distribute my power to everything right now and then divide. I think it's probably better to divide first. We need to stay in that habit of simplifying in the parentheses first. Okay, so 4 over 8 is going to reduce, that's 1 over 2. So 4 divided by 8 is 1 over 2. Okay, and then I'm going to look at the x's. I've got 3 and 1. So 3 minus 1 is 2. So x squared in the top. And then here I've got 2 minus 5. That's negative 3. So I need to put it in the bottom. Y to the third. Now all of this is still squared. You've still got that square on the outside. So now I'm going to take that power of 2 and I'm going to send it to everything in top and in bottom. Okay, it goes to everything. So 1 squared is still 1, which I don't have to write a coefficient of 1. So really I can drop the 1. And then 2 squared squared, remember you're multiplying the powers. So 2 times 2 is 4. So that's going to be x to the 4th. Okay, and then this orange 2 from the bottom, 2 squared is 4. So my coefficient down here will be 4. And then y cubed squared. So the 3 times 2 is 6. So y is to the 6th power. And like I said, I did the inside first and then the exponent on the outside. You could have distributed that first and then done your simplifying, but I think it was easier to simplify first. All right, so this one is more similar to the first one. Okay, we're going to find corresponding pieces. So the numbers, the coefficients, 3 and negative 2. So I'm doing 3 times negative 2. And then I'm going to corresponding the x terms. So x to the 4th and x. And then the y's are corresponding. So y squared and y to the 5th. If you can skip this line of regrouping everything and go straight to the answer, that's great. But a lot of people need to regroup it so they can see what they're doing. So the 3 times negative 2 is negative 6. Okay, remember this is an understood power of 1 if there's no power. And you've got like bases, so you're adding the exponents. So 4 plus 1 is 5. So x to the 5th power. Okay, and 2 plus 5 is 7. So y to the 7th power. Okay, last but not least. Oh, wait, that was last, wasn't it? There wasn't a 6th one. Okay, so I'll leave that up there. Okay, so these are reviewing our exponent rules, okay, and how to apply them to simplify expressions. So now you've got practice in Delta Math. I'm going to activate the day 5 practice. You still have day 1 through 4. Hopefully you've submitted some of those, all of them preferably, but at least some of them. If you choose to keep working on day 1 through 4 that aren't complete before you start day 5, that's fine, that's your choice, but don't forget to go back and do the day 5 practice. Okay, or if you want to do this one first while it's fresh on your mind, that wouldn't be a bad idea.